This lesson is about electricity being atomic. Electrons from atoms make up electricity, so understanding atoms and how they work helps us understand electricity better. So for our purposes, we just need to remember that atoms are made out of protons and electrons. They also have neutrons. Protons and neutrons are in the middle of the atom in the nucleus, and electrons are surrounding the nucleus on the outside. So normally electrons stay near or orbit, hover around the nucleus of an atom. Electrons want to be as close to the nucleus as possible. Why is that? There's a rule in our universe that opposite electric charges attract. And the protons in the nucleus are positively charged, the electrons are negatively charged, they're opposites, and so they want to attract each other. So we could understand that's why the electrons want to be close to the nucleus. But why don't they just spiral down and combine with the protons then if they're attracted by them? That was a great question. Physicists, it took a long time for them to try to understand what was going on with atoms. A real breakthrough came when physicists realized electrons are not really particles. They are somewhat like waves. They only exist at certain distances away from a nucleus, or the waves can't exist. For example, imagine this, the nucleus being the red marble in the middle, and I've just sketched a wave. Now if you reach that wave around, it can combine end to end and you have a complete wave. It just goes around. But if you shrink the size of that circle, the wave would not meet up with itself. It would cease to exist. So in essence, if electrons are like waves, they can only exist at certain distances away from the nucleus, or else they would interfere with each other and cancel themselves out. That explains why we have different colors of lights. Different colors, when you burn different chemicals, they're made out of different elements, they burn in different colors. It took a long time for people to understand why, so to simplify, imagine that this diagram, get the nucleus of an atom in the middle and 3 layers of electrons surrounding it, and imagine that you have a photon of light strike one of these electrons. If it has just the right amount of energy to give that electron enough energy to send it to the next level, but not too much or not too little, that electron can absorb that photon of light and jump to the next level. But it wants to be closer to the nucleus. It's unstable being farther away, so if it gives up the right amount of energy, it can drop back down to that more stable first energy level, and it'll give off that energy as a photon of emitted light. And so that's the reason that we see different colors of materials, is the colors of light that they are either absorbing or emitting. So electrons repel each other, and their locations depend on 2 things. The wave nature, defining the energy levels that they can exist in. Their location also depends on the positive pull or attraction from the protons in the nucleus, as well as the negative push or repulsive force from other electrons that are around them. So adding energy to an electron doesn't make it move faster, it just makes it move further away from the nucleus if it can absorb the right amount of energy. If enough energy is added, that electron can be removed from an atom completely and given to a different atom. But some atoms have electrons that are more easily removed than others. Electrons come in layers. This is another thing you learn in chemistry, is that the first layer of electrons, or the first energy level, can hold up to 2 electrons and would like to have 2 electrons to be the most stable. The second layer can hold up to 8, the third layer 18, fourth layer 18, fifth layer 32, and that's the largest atoms that we have. But what is the most common conductor of electricity? Of course, it's copper. Copper has 29 protons, and it will have 29 electrons to balance out the 29 protons. Protons being positive, electrons negative, so atoms are electrically neutralized. Those electrons come in 4 layers, using the rules we just saw. On the outer layer, which is called the valence layer, there's a single electron. Well, it's far away from those protons in the nucleus. It's also being repelled by all those electrons in between it and the nucleus. So if you give it just a little bit of energy, it can jump off that atom and onto a different one. So a single outer or valence layer electron is more easily removed from an atom. And the further away from the nucleus, the less the electron is attracted to the nucleus. The more layers of electrons between it and the nucleus, the more easily it can be removed from the atom. But what's a better electrical conductor than copper? Well, when you look at the periodic table of elements, copper is number 29. It's right here in this column. Everything in this column has one outer or valence layer electron. Silver, directly below copper, has another layer of electrons, so it's an even better conductor than copper. That single outer valence electron is farther away from the nucleus. It's repelled by 4 layers of electrons, so it's very easily removed. You'd predict that gold would be even better. It has a single electron very far away, 5 layers of electrons between it. But it turns out that silver is a better conductor than gold. Silver is actually the best electrical conductor. So why is that? We measure conductivity in a unit called Siemens. So silver ranks about 63 megasiemens per meter of length. Copper at 59.6, so pretty close. And gold at 45.2. So let's say we take silver, since it's the best conductor, we'll say set that equal to 100%. Say 100% conduction ability. If we were to compare copper to that, it would be 94.6%, pretty close. But gold, only 71.8% as good a conductor as silver. So I always wondered why gold is not as good a conductor. So I asked, and here's some answers I got from other scientists. There's really no simple answer to this question. But we use copper instead of silver because copper is less expensive, way less expensive. Roughly $2.30 a pound versus $214 a pound. And copper is way more abundant. 15 million tons a year are mined versus about 18,000 tons of silver. And it's nearly as good a conductor, 95% almost as good. It's actually better than gold. Why do some electronic components use gold? Well, we typically use gold plating on some electrical contacts because gold doesn't corrode. So especially if it's going to be used in, say, high humidity areas or outdoors, gold plating can be useful for that. But as a conductor, it's not as good. Copper is also ductile, means it can be pulled and stretched and malleable, bent. And so when you think about wire needing to be bent and turned and moved, copper is a very useful material for that. Hopefully this helped you understand electricity and electronics depending on our understanding of atoms. Understanding atoms really does help us control and use electricity more. And as we develop smaller and smaller scale electronic devices, we need to understand the nature of atoms better and better. The more we learn, the more we can do. And I always feel that there's just satisfaction and joy in knowing how and why things work the way they do. So thank you, hope you enjoyed it, and have fun.